after that disturbing infographic with about sugar intake, I just decided, dude, I gotta go to my happy place. So I went to University of Michigan's online histology site. Life is good once more. Do you remember? This is the pancreas. This is a microscope image of a pancreas. This is the real thing. And I'm showing you this because I want you to remember that the pancreas is 99% an exocrine gland, which means 99% of its cells are producing stuff, 1.5 liters every 24 hours, that is dumped into the digestive tract. Remember, the digestive system is outside our body, so if we're dumping fluid and digestive enzymes into the small intestine, then that's all exocrine function. 99% of it is responsible for this. This is the 99%. This and this is the 1%. The 1% are the islets of Langerhans, or the pancreatic islets. These guys are endocrine. You'll notice the cells look different, but there's also a blood supply here. There are blood vessels running through this. And this is where we're going to, number one, get the message from the blood. Whoa, there's glucose here, so we need to secrete some insulin. Number two, it's where we're going to secrete the insulin. So let's go look at the mechanism of this. Goodbye, University of Michigan histology site. I think that's the only time we've come to see that in our little friendly physio class. Sad story. All right, dog pounds, here we go. I'm going to make my beta cell gigantic. And I'm only making it gigantic so I can fit everything in so that you can still see it. Now, I need a blood supply. And the blood supply is going to offer two things to me. Number one, blood, after you just ate, is going to have a lot of glucose in it. So we're going to imagine a high concentration of glucose at this point. And here's the scoop. Your pancreatic cells have glut transporters. Now I'm just making this visual for you. So if we have glut, we're going to be able to transport the glucose into the beta cell easy, just down its concentration gradient. And the glucose, we have to remember that I have somebody in here who's going to be stoked to see the glucose. And this is not an intestinal cross-section. That's my friend, the mitochondria. Mitochondria are like, dude, give me more glucose. That's fantastic. So in comes the little glucose molecule. And what does the mitochondria burp out? How about some ATP? Here's your ATP. Now, this is where it gets really amazing. You have also embedded in this cell, you have these awesome special potassium channels. And they're super leaky little potassium channels, and they're open. If they're open, we know that potassium is going to be rushing out. So potassium in this open thing is just going to be rushing out. We're also going to have our sodium-potassium pumps that are keeping the membrane potential normal. But watch what happens. This is crazy talk. These potassium channels are called potassium ATP channels. And when ATP concentrations are high, do you get this? Why are the concentrations high? Because there's a lot of glucose in the mix. ATP concentrations are high. That's going to cause the potassium channel to close. Closing potassium channels. This is going to trap the potassium inside. So all of a sudden, my membrane potential is going to change. The membrane potential changing, this is so awesome. When the membrane potential changes, that stimulates or affects a voltage-gated calcium channel. This is, I'm going to have to write it down here, a voltage-gated calcium channel. And as the membrane potential changes, this guy opens. And what's going to happen? Calcium is going to rush in. So calcium comes into the cell. Now, take a second. What was this cell doing in the first place? Why are we even talking about this guy? Because, my friends, guess what's in here? Vesicles filled with, I'm going to make them like this, insulin. Because, hey, remember, we're in a beta cell. We're in a cell in the islets of Langerhans, and it's beta cells that produce insulin. And they're making these little vesicles filled with insulin hormone. Calcium, what does calcium cause? We've seen this before. Calcium binds to vesicles, and through the magic of magicness, what's gonna happen? Exocytosis. Seriously? Exocytosis is going to happen. And what is then going to be dumped into the blood? Is that, like, awesome? Okay, so now you've got insulin in your blood. So what? Who cares? Why do we care? Let's go find out how insulin works. Insulin's required for glucose to get into most of our cells. Let's go see how it works.